Okay, hey, welcome to example 10 in the Pyro tutorials, and in this tutorial we're going to take a look at gas solvers, or gas microsolvers as they're called. And we're going to take a look at what they do, what you can do with them, and also kind of explain what they are used for, as well as showing that the actual Pyro solver is built on these. So yeah, the standard setup in subs here, nothing out of the ordinary. We just have a sphere. Create some fields with a fluid source node, temperature and density. Add some noise, just the standard stuff. We add the null to know where to pick this up from. And we're gonna dive into the .NET. So disregard this for now. Just standard setup with a reset container, our smoke object, our source volume, and our Pyro solver. So on the Pyro solver, we're gonna go ahead and do one thing first. We're gonna go ahead and switch all of the things off in the shape tab, just to be 100% sure that we're not using anything there, which means that our simulation is gonna look like this without adding anything to it. Oh, sorry, that's actually me adding in this. We're gonna disconnect that, and it's gonna look like this. It's simply going upwards based on temperature because of the buoyancy. So that's it. That's all that happens. Okay. Now we're gonna start playing with microsolvers. So what is a microsolver? Well, microsolvers is actually what this Pyro solver node is built on. You can see in the shape tab we have dissipate, disturbance, shredding, sharpening, turbulence, and confinement. These are actually all microsolvers that is baked into this node right here. So turbulence is a microsolver called gas turbulence. And to take a look at the Pyro solver and actually explain that it is made of these nodes, we can right click allow editing contents, and we can dive in. And we can now see that it's a lot of nodes here. There's even more nodes in the next level, but here are some surface nodes, and let's take a look at the name of them. So here we have shape, operators, and forces. Right. So let's see. Here we have a node called gas turbulence. This gas turbulence is actually what is here, this thing. So when you do things in this, that's linked to this node right there. And we can actually access these nodes here and add them in like this. So just to take another look at here, we have gas turbulence, we have gas shred, gas vortex confinement, gas disturb, we have gas advect fuel, we have gas field VOP, we have gas calculate. There's a million, not a million, but literally like 150 gas nodes that you can build things of. Some of them I don't even know. Okay, I would say 70% of them I have never used in my life. And that's fair, because most of these things are actually built for you already. And I feel like gas nodes are probably what you want to use if you want to build your own solvers. And I haven't really done that yet. So here are all the gas nodes. If you type in gas, if you hit tab and type, let's hit tab up here and type gas, you can see there is a shitload of them. And only a handful is going to be relevant when you're doing Pyro simulations, all right? Some of these are for flip, some of these are for other things. But anyway, we are going to take a look at some of the most important ones. Called gas turbulence, gas disturb, gas damp, and gas wind. There is some more. There's gas dissipate, there's gas vortex confinement, there's gas blur, gas field VOP. There's a lot of them that are relevant to what you want to do, but we're gonna take a look at these, and I'm gonna explain kind of how to use them. Then you can go in yourself and like hit gas and just add in things and see what they do. All right, so I've just done this small little setup here, just to explain where you can use them and how. So if you want to use multiple gas solvers, that's totally fine. That's also an advantage of doing the gas solvers. So here we have 2 gas turbulence and 3 gas disturb, which is an advantage to our limiting here, which we only can have 1 turbulence and 1 disturbance. So these nodes, we have 2 turbulence and 3 disturbance, which means that we can get different frequency turbulence and disturbance. So we can have 3 different frequencies of disturbance and 2 different frequencies of turbulence, which can give us that extra push to get us an extra detail in there. But you always want to have to be careful when you're using multiple of this, because they can kind of cancel each other out, or they can make things go really crazy. So you really want to keep the scale of these kind of low, regardless. So if you want to use multiple, you can just use 100 of them and just add them into a merge. And then this merge, we're going to connect it to the third input on the Pyro solver, which is called velocity update. This means that they will be added to the velocity field, and they will do exactly what they are doing when they are here on the actual node. So what does this look like? So we have two turbulence now. One is a scale 0.6 and with a swirl size 0.5, and one is a scale 0.6 with a swirl size of 3. This means that this is really big and this is like slightly smaller than the disturbances we have at scale 0.3, but the block size 0.5. This is a small disturbance. Then we have a mid disturbance, which is at scale 0.3, but at block size 0.2. There's a mid. And then a big disturbance that is at scale 0.3 with a block size of 0.7. So all of this is combined and is now going to affect our volume or our smoke. Let's see what it looks like. So remember, when this was disconnected, it looked like this. All right, it just travels upwards. If we connect this to the velocity update port, it's gonna look like this. And to me, this is quite interesting. Like, it gives a really cool look to it. You obviously have to fine tune things. Get rid of these mushroom things and stuff like this, but it's quite crazy, but it's definitely a lot of detail. So you have to play with it, obviously, but you can definitely crank out a lot of detail if you use multiple of these. So that's kind of how to use them. All right. So now we're gonna disconnect this and we're gonna take a look at individual gas nodes. So let's drag these four in. All right. Let's just put them to the side a little bit like this, and then go over them one by one. So let's start with going on the turbulence. As remember, when we don't have any forces or any velocities acting on this, it only looks like this. It travels upwards because of the temperature or the buoyancy. So if we connect this turbulence to the third input, turbulence to the third input like this, we're basically going to do the same thing as we would if we turn this on, right? So this is a scale slider, 0.1. And then if you go to the terminals tab, you can do swirl size, grain, pulse length, seed, and all of these things. All the same settings that we have on this. The only thing that is different is that this slider doesn't actually say scale, it only says turbulence, but here it says scale instead. So this scale slider is exactly the same as this slider here. So you can kind of see this as a turbulence scale slider. So let's turn this off. Let's put this to 0.1. Let's put the swirl size to the same. So this was 1. And let's hit simulate. We now have a little bit of turbulence in there. Not too much, not too little, but it's looking quite cool. So that's basically how this works. We now done the same thing as the turbulence done on this, but we can obviously, let's bump it up, and we can make the swirl size a little bit bigger, 1.4, and it's gonna look like this. So that's just regular turbulence. It goes into the velocity field and it does turbulence on the volume. So let's disconnect this. This is how the turbulence works. Let's see about the gas disturb. All right. So disturb is the same thing. It kind of updates. It doesn't actually work on the velocity field, but it gives it an extra level of detail noise, which is the same as enabling it here. So disturbance 0.5. This is scale slider again. Disturbance, we have all the settings here, block size, cutoff field, field to disturb, and all these kind of things. All right. So in here, we do want to switch on this because we want to disturb the velocity field. So we want to switch on field is a vector field, and we don't want to do it on the temperature. We don't do it on the velocity. So that's it. And then we can put the disturbance to 1. And let's see what happens. As we see, we have this like fine frequency noise now, which is really cool. So that's how the disturbance works. It works the exact same thing as here. The only advantage is you can add multiple of them. So if you do a merge here, and we copy this, we merge them together, and we do this one to a block size of 3, and this one to a block size of 0.1. We turn down scale to 0.4 on both of them. Let's do 0.5 with that. Never mind. So what does this look like? Let's see. We're not gonna have 2 ranges of scale on this. It's a little bit hard to see when it's not high-res sim. When it's not a high-res sim, but you're definitely gonna be able to notice that once this is like rendered and simmed. So it's a very good practice to have at least maybe 2 disturbance going like this. Let's delete these. Let's delete the turbulence. Gas damp. All right, actually, let's add a turbulence for this. Let's add a gas turbulence and merge it together. Let's put the scale to 0.1, the swell size to 1, and yeah. So the gas damp is actually gonna act as a drag. We have used it before in explosion, so it's not new to us, quite as new as we can be. But we're gonna use a mask field. We're gonna use the density, and we are gonna lower the scale slightly to 0.7, and then we're just gonna take a look at what it looks like without it first. So the turbulence is gonna act on this now. We just have a little bit of turbulence going on, as well as it going upwards. So now if we add in gas damp, let's see what that looks like. It doesn't do much. Maybe we have to go a little bit higher on the scale. The scale is basically just like reducing the velocity. Yeah, we can now see that stuff is happening. It's still acted upon by the temperature, but the turbulence is going nowhere near as crazy. And that's because the turbulence velocity is reduced by this gas damp. We could, instead of doing density, we could do temperature. Like this. Let's see if that changes something. And it clearly does. It doesn't go anywhere near as high now, because we are acting this damp on the turbulence on the temperature field. So that's how you can use gas damp. Let's remove that, and now we have the gas wind. This is basically just a vector that acts as a wind force. So if we have a simulation here and we want to do some wind in this direction, in positive Z direction, we can put it to that vector, and we can do wind scale to 5, and we can hit simulate. And you can see we now have some wind acting on this. Maybe we're going to reduce this wind scale, and we can clearly see that it's going like this. And let's add some turbulence to that to make it a little bit more interesting. So let's put 2, 6, 0.0. Well, let's do 1.5. And let's see what that looks like. That looks quite cool. I like it. It could be like a windy smoke plume or something. Yeah, so that's kind of how these gas solars work. They're really, really handy to know, because you can take your simulations way further. And yeah, they're just fun to play around with, to be honest. They don't limit you as much. So that is kind of how they work. Read through this as well and take a look at these, because this is the description of what's happening here. But yeah, that's it for this tutorial. Thank you guys for watching, and I'll see you in the next one.